For thousands of years, we have been trying to understand how the universe works and how it is structured. And especially over the last 100 years, we've made pretty good progress in this. But then, it turns out that it doesn't exist.
Wait, what?
As our knowledge of the universe has advanced, it has grown larger and larger. What I mean is that first we thought that everything revolved around the Earth. Then it was limited to the solar system. After that, we thought that our galaxy was all there is. And now the observable part of the universe alone consists of hundreds of billions of galaxies. And in reality, it is probably even larger, possibly infinite. And this is without even mentioning the possibility of some version of a multiverse. So we've learned all this, but it doesn't stop some people from believing that everything beyond the Earth doesn't exist, and that all these galaxies and whatnot are just a hoax.
But by saying the universe doesn't exist, I didn't mean those guys. Today we're not going to talk about conspiracy theories. On the contrary, there are several hypotheses and ideas that came from actual serious scientists.
And according to these ideas, the universe, as we understand it, either does not exist or it is fundamentally different from what we think of it. There are several ideas that fit this description, and in this video I decided to compile several of them. So today, let's talk about whether our reality and the entire universe are an illusion. Could the universe be a hologram? We'll also touch on the popular idea that the universe might be a simulation. Let's discuss how these ideas emerged and arguments for and against them.
My name is Andrei, and this is Cosmos Elementary.
As I mentioned earlier, the phrase "the universe is an illusion" can mean completely different things. Let's start with a simpler idea, one that doesn't immediately cast doubt on the existence of the entire universe. But how much the universe really is as we perceive it is already a big question. A simple example, which I've already mentioned in my video about time, is colors. In a sense, colors don't exist. What we perceive as colors is simply how our brains interpret information received through our organs of vision about light. So information about electromagnetic waves with different wavelengths that are reflected from objects or emitted by light sources. We can't even be sure if we all see the same green or blue, or we just agree and call the top signal of the traffic light red, when in fact different people might see it differently. And this is just a small aspect concerning the visible part of the entire electromagnetic spectrum, which we have evolved to perceive. But think about how much more radiation in the universe that our eyes don't see. Infrared, ultraviolet, X-rays, radio waves, gamma rays, and more. If we're lucky, we see the night sky like this, but if we cheat a little bit and use a camera with long exposure, then it looks like this. It is still the same visible light available to us, we just can't accumulate light like cameras can. However, our Milky Way can appear at different wavelengths like this. Colors are usually arbitrarily assigned here, but the structure that is invisible in one range but visible in another is very much real. So first of all, our vision is capable of seeing far from everything that exists in the universe. Rather, we see only a very small part.
But our vision is also very easy to trick. All of you have probably seen some sort of optical illusions.
Pictures that seem to be moving but really aren't. These two squares that appear to be different colors but in reality they are not. Cars appearing to be different sizes but in reality, well, you get the idea. That darn dress. Even our moon, which looks huge near the horizon, although in reality its size is always the same. If we don't consider the small, sometimes barely noticeable real changes in apparent size due to the constant variation in distance to the moon as it moves along its orbit. So our eyes see very little of what actually exists, and it's easy to deceive them. How can we not suspect that everything we see is just an illusion? And that's just vision, only one of the classical 5 senses. The story with others could be similar. Sound is the vibrations of air molecules, how our auditory organs perceive them, and how the brain interprets them. And hearing can also be deceived, with plenty of examples of auditory illusions.
The situation with the sense of smell somewhat resembles what I've just said about our vision.
Only here it's not wavelengths, but various combinations of chemical substances that our brain interprets in one way or another.
And here, unlike with colors, we may even share how different our impressions might be. For some people, the smell of the same substance might be somewhat pleasant, while for others it could be repulsive.
Taste can also be tricked. Moreover, it's important how different senses work together. For example, with blindfolded eyes and a blocked nose, one may not be able to identify the taste of a familiar food.
Even touch is, in a sense, an illusion. You might have heard that we actually never touch anything. More precisely, at the level of particles, electrons in my hand repel electrons of the things that I touch.
And between everything we touch, there is still a distance. Very small, but it's there. And the sense of touch ultimately is also a kind of illusion. It's how our brain interprets the interaction of particles and the force of their repulsion from each other. So each of our senses can be fooled, and almost everything we ultimately perceive is just a limited interpretation by our brain, and in a sense, an illusion. Plus, much of it depends on our experience. How can we then be sure that the world around us is truly as it appears to us? Well, we can't. We only perceive a part of it and interpret it as best as we can. And while it's interesting to think about it, at least it doesn't cast doubt on the existence of the universe itself or its fundamental nature. But other attempts to label the universe as an illusion do exactly that, and one of the most popular such ideas is the simulation hypothesis. To be honest, a lot has been said about the simulation hypothesis. There's videos, articles, and books. But still, I also want to touch on this topic a little. Perhaps among you there are some supporters of the idea that our universe is a super complex computer program created by some highly advanced civilization, and we are just like characters in a game. It sounds wild, of course, but strangely enough, this idea has some notable supporters, one of whom is none other than Elon Musk, who once stated that we are most likely living in a simulation, and the chance that we are in the base original reality is 1 in billions. Well, Elon Musk does say a lot of things, but scientists also enjoy pondering the idea of a simulated universe. The idea that our reality could somehow be artificial and have creators is not new, even if we set aside religious stuff. But one of the main proponents of the idea in its modern form is professor at the University of Oxford and a philosopher Nick Bostrom. In 2003, he published a paper called "Are You Living in a Computer Simulation?", where he presented arguments in favor of high likelihood that we are in a simulation. And today, perhaps most articles on the simulation hypothesis mention Nick Bostrom or his arguments in one way or another.
Naive ideas about simulation go something like this.
Today, scientists are capable of creating computer simulations, including models of the universe at various scales. Also, video games are becoming increasingly complex, visually approaching photorealism. Considering the constantly growing computing power, the development of simulations and virtual worlds, it is easy to imagine that in the future, all of this will evolve to the point where we can simulate a world or a part of it that is indistinguishable from reality. And a civilization that has evolved for hundreds or even thousands of years longer than us might be able to create and populate this world with artificial intelligence that wouldn't be aware that it's in a simulation. The essence of Bostrom's article can be summarized by 3 somewhat mutually exclusive statements. 1. All intelligent civilizations in the universe become extinct before they reach a stage of development where they can create simulations of the universe. 2. These civilizations reach such a stage of development and have the capability to create simulations, but for some reason they choose not to do so. 3. We almost certainly live in a simulation.
Wait, why is that? Why immediately go there?
The point here is that if creating such a simulation with intelligent virtual beings is possible, then the number of simulated beings could vastly outnumber the number of real physical beings. And if there are many simulations themselves, in short, in such a scenario, statistically speaking, the chance of any given intelligent being, being virtual rather than real, is much higher. I'm not sure where Musk got 1 in billions chance from, but probably the reasoning is similar. If simulations of universe exist, and there are a billion times more intelligent beings in them rather than in reality, then the chance for you and me to be real rather than virtual is 1 in a billion. And the conclusion is that most likely we are in a simulation. And this is the third point of our trilemma. And if we don't live in a simulation, it means that either intelligent civilizations don't reach such a technological level, or they don't create simulations.
And that is one of the main arguments, but do you see the problem in all this?
Well, firstly, here we have to assume that other intelligent civilizations even exist, and we simply don't know that yet. Secondly, we have to assume that creating simulations as complex as our universe is even possible, which we also don't know, and there are arguments against it.
So to claim that we live in a simulation based on solely such a rather philosophical reasoning, well, that's debatable. But are there any other arguments?
The simulation hypothesis could potentially address some modern problems discussed by scientists, for which there is currently no definitive answer or no answer at all. For example, the problem of the fine-tuning of the universe. I had a separate video on that topic.
To put it briefly, as suggested by the name of the problem, our universe seems to be fine-tuned for our existence.
Modern physics describes the universe with a set of parameters, including a dozen or so fundamental constants, each of which has a specific value. So it is believed that if the value of even one of them differed from what we have now, not only would there be no intelligent life in the universe, but the universe itself could look completely different, lacking the familiar structure of galaxies, stars, and planets. In the case of some of those parameters, it would be enough to alter them just a little, and also there are many of them. So it seems that the probability of all of these parameters taking on exact values necessary for the existence of the laws of physics, structures, and subsequently life is very, very low. And that's why some people come to a conclusion that either we got really lucky, or someone deliberately set those parameters of the universe so that life could exist. Someone programmed the universe. Therefore, the universe is a simulation. But, of course, this is not the only way to solve this problem. Among other solutions is the existence of a multiverse, and consequently universes with different parameters. Well, and simply blind luck. Even unlikely events do happen sometimes. You can find more details about the fine-tuning problem in my video. I'll leave a link to it in the description. Also, the simulation hypothesis seems to be able to address the famous Fermi paradox, which asks, if the universe is so vast, where is everybody? Where are the other intelligent civilizations, and why haven't we seen anyone else? So here we don't see anyone because there is no one else, and we live in a simulation, and only we have been programmed.
Some people might find that convincing, but probably there are more skeptics, and that's not without a reason.
The fact that we are currently able to create some simulations and games that sometimes resemble reality doesn't necessarily imply anything. Modern simulations that model the evolution of the universe are not simulations of the entire universe. In such large-scale simulations, there aren't even individual planets, and entire galaxies can be represented by individual particles. That is, a galaxy is even divided into individual stars. And the larger the scale of the simulation, the less detail there is. If the evolution of the individual galaxy is being simulated, then, on the contrary, the large scale of the universe is not simulated there. Furthermore, when it is said that the laws of physics are taken into account in simulations, it doesn't mean that they are modeled there exactly the same way as in reality. We can only do this to a certain approximation, with a certain degree of accuracy. Even though computer models in science are a very important tool today, it is impossible to rely solely on them. The predictive power of models is valuable when we can compare simulation results with real observations. You can't write a program for the evolution of a galaxy in isolation from the real world, observe how it behaves, and call it a discovery. What models produce is compared with real galaxies, and if the model accurately reproduces what we see in reality, then the model can be useful. For simulating large-scale structures of the universe or detailed simulation of particle behavior on microscopic scale, only a small area can be simulated, and it still requires supercomputers. To model our universe with all its hundreds of billions of galaxies down to the subatomic scale, we would need unimaginably powerful computer. Yes, these capabilities are growing, and indeed a modern smartphone would astonish someone from the 80s with its power. However, can this power grow infinitely?
What's the point of expending so much effort and energy to simulate the entire universe?
I've already started discussing the issues with Bostrom's reasoning. In his version, such a civilization might attempt to precisely recreate its own universe. Perhaps to study the evolution and development of their own universe and civilization, or to make predictions about their future based on a super accurate model. If you know all possible information about a system, theoretically you can predict its evolution. But in this case, the problem of recursion arises. The computer on which the simulation is run is also a part of the universe. So, to recreate the universe exactly, you'd have to create a computer on which the simulation of the universe will run, in which there will be a computer, on which there will be a simulation of the universe, in which there will be a computer. Well, you get the idea. With such an infinite loop of repeating entire universes, you'd need infinite computing power from the original computer, which would probably have hard time doing all that. You could recreate the entire universe and just exclude the computer from it, but then it wouldn't be an exact simulation. In the universe, everything can interact with something else, and if you remove part of the particles in the form of a computer, who knows what inaccuracies that would lead to. Like the butterfly effect and all that. You wouldn't be able to make precise predictions using this model. And what's the point of it? And these aren't even all the problems. If elementary particles were simply tiny solid spheres, and you could just accurately describe the position and velocity of each particle in space, then with enormous computing power, you could simulate it. But in our universe, that's not the case. Elementary particles have a dual nature and can be represented as both waves and particles. At the quantum level, probability and uncertainty reign. It's impossible to know all the parameters of a particle exactly. For instance, you can't determine the exact position of an electron, only with a certain degree of probability. And how would you simulate that? Even quantum computers might not be able to help with that. Another problem is that our universe is likely infinite. While we can only observe a part of it, moving in any direction would reveal new regions of the universe to our observation. Again, I had a separate video on this and the horizons of the universe. And how would you simulate an infinite universe? There have been studies indicating that it's physically impossible to create such a computer because there aren't enough particles for it. Again, one might think that the base universe is even larger, but that's another assumption added to the ones we already made. Plus, you have to assume that simulating consciousness is even possible in principle. In general, any hypothesis will remain just that, a hypothesis, if we don't try to test it somehow. There were assumptions that if our universe were a simulation, some unexpected behavior might be observed in certain cosmic phenomena, for example in the energy of cosmic rays, but nothing like that has been found. Also, just as computer code consists of bits, the space-time in a simulation could be not continuous but made up of smallest units. Experimental attempts to find them have been made, but so far they have been unsuccessful. This doesn't mean that they don't exist, but rather that we haven't seen them yet. In general, to theoretically entertain the possibility that we live in a simulation, one must make many very serious assumptions, and the idea has a lot of problems. There are also no experimental data supporting this idea so far. Considering all this, we certainly cannot confidently say that we live in a simulation, like some people do. Another idea according to which the universe may not be what it seems and, in some sense, an illusion, is the idea that the universe is a hologram, and it differs from the simulation hypothesis. This is not just an amusing concept to ponder, it's a specific tool that scientists use when attempting to solve certain problems in physics. Scientists are actively researching this issue, and there are quite a few scientific papers on the topic. The topic is indeed quite complicated and we won't delve too deeply into it, but let's try to understand what is meant when people say that our universe may be a hologram, why this idea is proposed and whether it is even possible. So the idea is that our entire universe, our familiar world with 3 spatial dimensions and 1 dimension of time, is a projection from some distant 2-dimensional surface, where information about our world is encoded. Similar to how a flat hologram creates the illusion of depth and 3-dimensionality of the object depicted on it, but still this 3-dimensionality is just an illusion. So is our universe and its 3-dimensionality, in some sense an illusion.
It sounds wild, I agree, and in fact nobody's claiming that our universe specifically is for sure a hologram. Where does this idea come from in the first place?
For this we can thank black holes. One of the main unresolved problems with black holes is the paradox of information loss in black holes. This paradox arises when attempting to apply not only general relativity but also quantum mechanics to describe black holes. There are more familiar laws of conservation of mass and energy. Energy cannot come from nowhere and disappear into nothing, but in modern science there is also a similar principle that applies to information. Here by information we mean not just text on a paper or files on a flash drive, but the complete physical information about a system, the description of each particle. Even if we destroy an object, let's say burn a piece of paper, possessing full information about each particle, how it moved, what happened to it, theoretically we can determine what the resulting ashes used to be. But with black holes this doesn't work. If something falls into a black hole, it seems to become forever disconnected from the universe, which in itself is not a problem. The problem started when Stephen Hawking applied quantum theory to black holes and found that black holes can actually evaporate. And in the end they disappear completely. And the mass of the black hole returns to the universe in the form of particles like photons and neutrinos. And from them, it is impossible to reconstruct what the substance that fell into a black hole had been. This means that information is completely destroyed, which contradicts the principle of information conservation. And I had a video dedicated to this paradox, where I covered it in more detail. There are several possible resolutions to this paradox and ideas about how information is not destroyed but rather returns to the universe. But what's important for us now is that one of these solutions to the paradox was the proposal of the holographic principle. The idea was proposed by one of the fathers of string theory, Leonard Susskind, and the Nobel laureate in physics Gerard T. Hooft. Without delving into details, the story goes like this. When an object falls onto a black hole, information about the object remains as a sort of imprint or is encoded on the 2-dimensional surface at the event horizon of the black hole. And when Hawking radiation leaves the black hole, the information becomes accessible again.
While it may all sound quite strange, it's not just some wild fantasy.
The idea has specific mathematical solutions. Furthermore, calculations show that the 2-dimensional surface could fit enough information to describe 3-dimensional objects that have fallen into the black hole. This is where the analogy with hologram arises, at least in its naive form. Holographic images are also 2-dimensional surfaces on which we can sort of see 3-dimensional objects. Another issue related to these problems is the problem of black hole entropy, where, in resolving the problem, a 2-dimensional surface, or the area of the event horizon, also emerges.
But okay, black holes are black holes, but what does this have to do with the entire universe?
There's also the hypothesis that our universe could be a black hole. I mean that we live inside a black hole. The thing is that holographic principle applied to black holes inspired physicists to apply similar logic to the entire universe. And it turned out that if we consider the universe as a 2-dimensional object that just looks 3-dimensional, It helps to solve a number of serious theoretical problems in physics. Physicist Juan Maldacena developed a model of a hypothetical universe that could be a hologram. In this model, he managed to make string theory work better, and according to him, in such a universe it's possible to unify general relativity and particle physics. In modern physics, this is probably one of the main, if not the main, challenges, constructing what's known as the theory of everything. In short, in his model, if the universe were a hologram and information were contained on some distant two-dimensional surface, while three-dimensionality were just an illusion, mathematics works in such a way that some fundamental physical problems can be solved. But does this mean that our universe is a hologram? No. In Maldacena's work, a very specific model of the universe is described. And it's different from our universe. For example, the geometry of space there is different. It's not flat like in our universe, well, as far as we know. Nevertheless, scientists are trying to apply the holographic principle to our universe, and they might succeed in doing so eventually. By the way, one of the arguments sometimes used in favor of the idea that our universe might be a hologram is the strange effect of quantum entanglement. The fact that there is a strange connection between two entangled particles, and they seem to influence each other even when they're separated by vast distances, with changes in state of one particle leading to changes in state for the other, faster than the speed of light. And the idea that everything is actually on a two-dimensional surface can help explain this strange effect. The conclusion here is that the idea of the universe as a hologram is a convenient mathematical tool used for convenient calculations and is employed in an attempt to solve a number of serious physical problems. So when we don't understand something in the universe, we explore possibilities and various models in which calculations might work, and this is one such approach. In some cases, it is more convenient to consider the universe as two-dimensional, but that doesn't mean that the universe is actually a hologram. But could it actually turn out to be one? In principle, it could, and if so, then indeed our three-dimensional world in some sense is just an illusion. However, there is still no experimental evidence to support this. Is the universe really as we see and feel it? No. Are we living in a simulation or a hologram? For now, we cannot say that for sure, just as we cannot assert the opposite. And if that's really the case, it's unlikely to have any impact on our everyday lives. But it could help us better understand the fundamental structure of the universe.
Thanks for watching. Links to all of the sources are, as always, down below in the description, and if you enjoyed the video, leave a like, comment and subscribe for more videos in future. Bye!